Welcome to the Chemistry of Pain Medicine by Grayson and Hank, our end of the year chemistry project. So we're going to start with the definition of pain medicine, and that is a discipline within the field of medicine that is concerned with the prevention of pain and the evaluation, treatment, and rehabilitation of persons in pain. And we got that from the source ABPM. So in simpler terms, it's just when someone's in pain, they'll take pain medicine and it'll sort of calm their nerves so they don't feel that pain as intensely. So we're going to move on to the types of pain medicine. One type is acetaminophen, and this is a non-aspirin pain reliever that is safer for children to use. It relieves fever, headaches, and other various pains, and it does not relieve inflammation. That's very key. It does not relieve inflammation. And some examples of acetaminophen would be Tylenol, paracetamol, and Panadol. And we got all that information from Medline Plus. Another type of pain medicine would be NSAIDs or NSAIDs. These do relieve inflammation. That's sort of a main separate piece from acetaminophen and NSAIDs. And they relieve fever, pain, and swelling. Some can be bought over the counter, and others must be prescribed by a pharmacist at like CVS or any pharmacy like that. And some examples of NSAIDs would be aspirin, ibuprofen, and naproxen. And we got all that information also from Medline Plus. And as you can see to the right, there's a picture of Aleve. Aleve is definitely a example of NSAIDs, as they contain some of the ingredients of the examples. Another type of pain medicine would be opioids. These are only prescribed by doctors. They are much stronger than over-the-counter medicines and are addictive once taken too much. If not taken correctly, one can experience serious side effects, which can include overdose and risking the chance of someone dying. And we got all this information from the source of WebMD. And some examples of commonly prescribed opioids would be prescribed by like doctors at CVS or whatever. And some of these examples would be codeine, fentanyl, hydrocodone slash acetaminophen, hydromorphone, meperidine, methadone, morphine, oxycodone and acetaminophen, oxycodone and naloxone, and we got all of that also from WebMD. So now we're going to focus on just one precise, specific, whatever, painkiller, and that's ibuprofen. And so we're going to go through some of the physical and chemical properties of ibuprofen. And so the formula of ibuprofen, the chemical formula, is C13H18O2. And the molecular weight is 206.28 grams per mole. The boiling point is 157 degrees Celsius, and the melting point is 75 to 77.5 degrees Celsius. And for its state, it's a colorless crystalline solid, and we got all of that information from the source of PubChem. And as you can see to the right, the 2D structure and the 3D structure of this chemical formula of ibuprofen is stated. Now we're going to look at the history of pain medicine. And for thousands of years, opiates derived from opium poppy have been used as a form of pain medicine. So that dates back all the way to like the year 1000, just a long time ago. And pain medicine was first extracted in pure form in the 1800s. So back thousands of years ago, when they were using opium poppy used as opiates. It was not in the pure form, and so those were first introduced during the time of like the Civil War. And the first drug to be extracted in this pure state was morphine, and it was heavily used in the Civil War, and many soldiers became addicted to it very quickly. And as time went on, more drugs were introduced into the field of pain medicine, ultimately leading up to the hundreds types of painkillers that exist today. And we got all this information of the history of pain medicine from the source of Drug Free World.
How does Advil work? Advil does not actually work where the pain is occurring. Rather, it works in the nerve endings, in the nervous system, and in the cells. When you are injured, the cells in the area release prostaglandins. These prostaglandins come in contact with the nerve endings in the area. These nerve endings are very sensitive to this chemical. When they sense it, they send messages to the brain to let the brain know that something has just hurt you. Taking a pain medicine like Advil will stop the cells from producing prostaglandins, hence lessening or stopping the pain. Rather than just relieving pain, Advil can cause other side effects, such as nausea, dizziness, ear ringing, mild heartburn, or a rash. Taking too much Advil may cause bruising, bleeding, internal bleeding, or blood loss. This may be linked to other underlying illnesses, though. Since Advil changes the production of prostaglandins, and prostaglandins help keep the right pressure in your kidneys, taking Advil may lead to increased blood pressure, dehydration, and dizziness. These are all due to the fact that the pressure in your kidneys has changed. While taking Advil with other drugs, they may affect the way that Advil works, and you may bruise or bleed more easily. These drugs can include cyclosporine, Pemetrexed, lithium methotrexate, blood thinners, heart or blood pressure medication, and steroid medicine. For those allergic to Advil, the reaction they could have can be very serious and may include hives, facial sweating, asthma, wheezing, shock, skin reddening, rash, or blisters. According to Advil, the uses for Advil can include a headache, a toothache, backache, the common cold, muscle aches, minor pain of arthritis, and it temporarily reduces a fever. What is the difference between Advil, ibuprofen, and Tylenol, acetaminophen? Tylenol only relieves pain and fever, while Advil too relieves pain and fever, but it also serves as an anti-inflammatory drug. So, we wanted to find the answer to the question of which dissolves faster, Advil or Tylenol. So for our experiment, we will test to see whether Advil or Tylenol dissolves faster after 5 hours in water. The materials we used were 2 Tylenol pills, 1 whole, 1 separated, 2 Advil pills, 1 whole, 1 separated, 4 glasses for the water, a half cup full each, and the water 105 degrees Fahrenheit to 110 degrees Fahrenheit. A spoon to stir, and 2 shirts to filter the water through at the end. The procedure we use is we cut one of each of the pills in half to limit the resistance of the shell. We left all 4 of the pills in different glasses of water for 5 hours. We stirred at 2.5 hours, and after 5 hours, we filtered the water through a sleeve of a shirt to see which of the pills had dissolved the most. Here are the pills before the experiment. On the left side are the Tylenol pills. In the back is the whole, and in the front is the separated. On the right side is the Advil pills. In the back is the whole, and in the front is the separated. Here's a video of the dissolving of the pills occurring. So as you can see, at 2.5 hours, halfway through, I stirred each of the 4 glasses to speed up the dissolving of each of the pills. After 5 hours, these were the results. On the top left is the separated Advil, and at the bottom left is the separated Tylenol. In the top right is the whole Advil, and in the bottom right is the whole Tylenol. Between both of the separated pills, the Tylenol pill was clearly dissolved more. And between both of the whole pills, the Tylenol pill was also clearly dissolved more. In conclusion, both of the Tylenol acetaminophen pills dissolve faster than the Advil or ibuprofen pills. So this would lead me to believe that acetaminophen pills will halt the production of prostaglandins faster than ibuprofen pills because they dissolve faster, hence working faster. Here are the works that I used, and here are the works that Hank used.